Let's now set up the boundary conditions for our flow analysis. For any flow analysis, we need at least one velocity and one pressure at the inlet and the outlet. Using my boundary conditions drop-down in our Fluids tab, I'll add a pressure block and a velocity block to my notebook. We typically assign velocity at our inlet and pressure at our outlet, so I'll go ahead and make these into variables and name them accordingly. I'll right-click on my velocity to make it a variable called inlet velocity. I'll do the same for my pressure and call it outlet pressure. Scrolling back down to our flow analysis section, I can go ahead and reference both of those variables within my boundary conditions list in my flow analysis block. I'll add a list item and drop in my velocity and my pressure. Let's begin with our inlet. We want our fluid to enter our fluid domain at 10 millimeters per second. We can easily assign this velocity using a vector in that velocity input. We'll assign a vector of -10 by 0 by 0 millimeters per second. Now we've assigned our velocity, but we still have to assign the location of that flow. To do that, we'll assign a boundary using the virtual boundary by body block. We can find this in our utilities dropdown, or we can double-click within our velocity block and add our virtual boundary this way. This virtual boundary by body has 4 inputs: an implicit body that we use to select our boundary, an option to reverse our selection, a tolerance for our implicit body's boundary, and a domain body. The domain body is how we define our domain that we want to place this boundary on. We've already built our fluid domain for our simulation model, so I can drag and drop that fluid domain into our domain body. Now let's add our selection body using a simple primitive implicit cube. From our Create tab, I'll use our primitives dropdown and add a cube to our notebook. I can drop it into my body input, locate it in my viewport, and drag its center point toward my inlet. Zooming in, maybe I want to resize this so that I capture my entire inlet. I'll resize it to 15 millimeters. View the result, and now I see that I've got some level of overlap. As a rule of thumb for flow analysis, we want this overlap to be about 3 times the cell size that we assign later. To help visualize my overlap, I can go into the display panel of my cube and adjust my transparency. Now that we've created this overlap, I see this yellow velocity glyph indicating that we've successfully implemented our inlet velocity. For clarity and organization, I can right-click on that virtual boundary we created and make it a variable called inlet boundary. I'll collapse my inlet blocks, and now we can move on to our outlet. Zooming back out on my model and moving over to the other side, this is where I want my outlet to exist. Similar to what we did before, I can double-click into my boundary input and add another virtual boundary by body. We can make our body another cube and use the same domain body as we did last time, our fluid domain. To assign our cube, we can go into our Create tab and add another primitive, or we could even copy the initial cube that we made and paste it into our body input. Now I can just take that same center point as we used last time and drag it over to the other side of my model. And we'll see this new cube appear. I can make this display transparent as well. And making sure that we've captured our entire end. We've now assigned our virtual boundary to our pressure. I can right-click and make that into a variable called outlet boundary. Then add my pressure magnitude. I'll assign this as 101,325 pascals, or simply 1 atmosphere. Zooming in, we see this new glyph appear, and we can see it even more obviously if we isolate our outlet pressure using the hotkey I. So now I can collapse all of my blocks, maybe turn on the visibility of my fluid domain, and both my inlet velocity and my outlet pressure. At this point, I've successfully set up my simulation model and applied my boundary conditions.